Hey, what's up, everybody? Mr. Rowan here, and we're starting our first day of solids. We're going to start things off with surface area, and I'm going to try to breeze through this about as quick as I can, because the thing with all these is that mostly it's really formula based, and you can find any formula you need just through Google. So, starting things off, surface area of a sphere. It is 4 pi r squared. So we're going to move down to our prisms. So a prism, it's a 3D figure, and all the faces are polygons. So the bases, those are going to be the parallel sides. So you see here, this is a pentagon as bases. We call it a pentagonal prism if you want to be fancy. But what this means is that the pentagons are our bases, and you'll notice how they are parallel and they are congruent. Now, there's a bunch of vocabulary terms for you. The vocabulary terms are not going to be super duper important. They're just kind of signposts in our class to point out some of the things that we're going to be talking about. So the basic idea that you have to understand here is for prisms, the surface area is really just going to be the sum of all of the polygon faces. So what that comes down to is when you're looking at a rectangular prism, which is the most common type that we see in our everyday lives, because things like, cardboard boxes, those are just rectangular prisms. That area is going to be 2 times the length times the width, plus 2 length times height, plus 2 width times the height. And just to be more general, we say that the surface area is HP, so that H is going to be the height, and that's the height, when you're standing it on its base. So the height is going to be H, and then the P is going to be our perimeter. And then B, notice how we have it as a capital B. That's sort of our way of adding the second dimension to it, because the capital B is going to be the area of our base. Cool? So I'm not going to walk you through all the steps to plug it into the formula. I think you guys can plug things into formulas pretty well. We're just going to go on to a cylinder. And you can think of it as like a prism where the base is a circle. So we have 2 circles and they're parallel. Okay. And if you want to be a little bit more specific, every cylinder that we come across in our lives is going to be a right cylinder. That just means that that each circle makes a right angle with the sides. So it's very uncommon to ever see a cylinder that's not a right cylinder. And so the surface area, it's going to be pi r squared for the top and pi r squared for the bottom, because those are the area of our caps. And then it's the same kind of general idea as what we saw before with a prism. So we multiply the height by just the distance around the shape. So that's where the pi r h comes from. Okay, because the circumference of our circle is 2 pi r. Don't forget that. So let's move on to pyramids. I'm sure you guys have all seen these in your elementary school social studies class with the Egyptian pyramids. But in geometry terms, it's just a shape that has a base that's a polygon and then a vertex at the top. So all the edges basically meet at one point at the top. So all of the faces are going to be lateral faces, and then we have a base at the bottom. The lateral faces, they end up being triangles because they connect two vertices at the base, and then they have one vertex at the top. When we talk about the height of our pyramid, there's essentially going to be two different ways of measuring the height. There's the vertical height, and then there's the slant height. So the slant height is it's the distance along the edge of the face. Okay, so the height of a lateral face. Okay. So when we start looking into what these formulas mean, it's pretty easy to find these formulas, but you want to know exactly what they're talking about. So it's important to realize that when you see the formula that says surface area equals 1/2 LP plus B, well, what they mean by that is that L is the slant height, and P is the perimeter of the base. And then capital B, the same way it was with the prisms, it's just going to be the area of the base. Okay, so you should be able to plug in all that information. Now, one thing that you may occasionally come across is they might give you the vertical distance, the vertical height, and in that case, you just have to use the Pythagorean theorem to figure out what the slant height is. Moving on from that, a cone, it's sort of like a pyramid where the base is a circle, right? Anybody who's been to Ben and Jerry's should know what a cone looks like. And I would say that the mathematical properties are not that difficult. And you can see that there's right cones and oblique cones, which is a right cone that goes straight up and down, and oblique is where the vertex is not directly over center. We're going to mostly be focusing on right cones in our class, but the formulas are actually the same. So the surface area is going to be pi r and then L plus r. And you can probably guess that r is going to be the radius. You know what pi is. And then L is just going to be the slant height of our cone, just like it was with the pyramid.